Hello Pharma guys, welcome to our channel Easy Learn Pharma. So today I am going to discuss about the most important part of the emulsion. So what is that? That name is emulsifying agent. So why the emulsifying agent is the most important part of the emulsion? What is the reason behind this? You should know without emulsifying agent you can't prepare the stable emulsion. Okay, without emulsifying agent you can't prepare the stable emulsion. That's why the emulsifying agent is the most important part of the emulsion. Okay, so today's class I will discuss about the emulsifying agent, their classification. Okay, their classification, and another thing is how to choose the best emulsifying agent for the preparation of O by W type of emulsion or double by O type of emulsion. So today's class I will discuss regarding what do you mean by emulsifying agent and what are the classification of emulsifying agent according to the different sources, and the next thing is or how to choose the best emulsifying agent for a particular type of emulsion, that may be O by double type of emulsion or double by O type of emulsion. So first thing is, before going to the emulsifying agent, first of all you should know what are the classification of emulsifying agent according to the different sources, so that you can easily understand what I am telling regarding the emulsifying agent. So let's see. So first is the classification of emulsifying agent according to the different sources. Clear? Sources, it is classified into 5 categories. One is natural sources, semi-synthetic sources, synthetic sources, inorganic sources, and organic sources. Okay, so from the natural sources, which type of emulsifying agent you have to collect it? From the semi-synthetic sources, which type of emulsifying agent you have to collect it? From the synthetic, which type of emulsifying agent you have to collect it? From the inorganic, which type of emulsifying agent you have to collect it? And for the organic part, which type of emulsifying agent you have to collect it? So according to the different sources, you have to collect it from the so many or multiple numbers of emulsifying agent. Okay, so first one is the natural. Okay, is the natural sources. So from the natural sources, you have to collect so many numbers of emulsifying agent. The natural source again divided into 2 types. One is vegetable source, another one is the animal source. Okay, so from the vegetable sources, which type of emulsifying agent you have to collect it? Now first one is gum acacia, tragacanth, agar, starch, and pectin. Okay, so these are the emulsifying agents that coming from the vegetable source of natural sources. Okay, so in the exam point of view, so many questions will be arise: gum acacia, tragacanth, agar, starch, or pectin. Which type of emulsifying agent? You can say these are the source of vegetable source from the natural sources. Okay, so these are the vegetable source of emulsifying agent. So what are there? Like gum acacia, tragacanth, agar, starch, and pectin. Clear? Some of the question, some important part from this emulsifying agent: starch, okay, tragacanth, and gum acacia. These are the most important emulsifying agent coming from the vegetable source of natural sources. Clear? And the second thing is animal source. Okay, so from the animal, which type of emulsifying agent you have to collect it? The first one is wool fat, second one is the egg yolk, third one is the gelatin. So these are the emulsifying agent you have to collect from the animal source: wool fat, egg yolk, and gelatin. In the exam point of view, wool fat and gelatin is the most important emulsifying agent. Okay, gelatin is the emulsifying agent which coming from which sources? You can say that is the coming from animal source from the natural sources. Clear? And the next one is the semi-synthetic sources. From the semi-synthetic sources, you have to collect 2 emulsifying agent, that is methyl cellulose, another one is the sodium carboxy. Okay, so these are the 2 emulsifying agents coming from the semi-synthetic sources. Next one is the synthetic sources. Okay, so from the synthetic sources, which type of emulsifying agent you have to collect it? Now one is anionic, second one is cationic, third one is the non-ionic. So these are the 3 emulsifying agents coming from the synthetic sources. Next one is the inorganic emulsifying agent. Okay, so first one is the milk of magnesia. Second one is the magnesium cate. Third one is the magnesium trisilicate. Okay, so these are the number of emulsifying agent is coming from inorganic sources. And the last one is the organic sources. So which type of emulsifying agent you have to collect from the organic sources? Now one is carboxyls, next one is the cholesterol, and third one is the lecithins. Okay, in this the cholesterol, lecithin, and carboxyls, these are the three emulsifying agents are the most important emulsifying agents that are used in the research purpose of the liposome. Okay, so lecithin, cholesterol, and carboxyls, these are the organic emulsifying agent. Clear? So these are the classification of different type of emulsifying agent according to the different sources. Clear? So natural source, semi-synthetic source, synthetic source, inorganic source, and organic source. Clear? So let's see what do you mean by emulsifying agent, or what is the importance of emulsifying agent in the preparation of stable emulsion. So let's see. So let's see emulsifying agent. Already I had discussed regarding the classification of emulsifying agent according to the different sources. So now come to the point. Actually, what do you mean by emulsifying agent? What is the importance of the emulsifying agent in the preparation of stable emulsion? Why the emulsifying agent is the most important parameter in the emulsion? So there are so many questions will be arise in your mind. So in today's class, all the questions, all the problems will be solved. Okay, so how? So let's see what do you mean by emulsifying agent. Emulsifying agent, what is the importance of the emulsifying agent? So before going to the definition of emulsifying agent, first of all, I'm giving one example so that you can easily understand what do you mean by emulsifying agent and what is the importance of the emulsifying agent. Okay, so all of you know what is the simple composition or what is the main ingredients of the emulsion. Okay, all of you know what are the main ingredients of the emulsion. Let's see what are the main ingredients of the emulsion. Oil and water. Okay, so these are okay, so these are two things, so these are the two liquids are the main ingredients of stable emulsion. Okay, so why the two? So my question is that why these two liquids, okay, why these two liquids are not miscible with each other? Why these two liquids are not miscible with each other? So my question is that, my dear students, so why these two liquids, why these two liquids are not miscible with each other? Okay, so what is the reason behind this? So the first reason is, what is the reason? And the first reason is due to due to interfacial tension, due to interfacial tension between the due to interfacial tension between the oily phase and aqueous phase. Okay, so the first reason why these two liquids are not miscible with each other, so the first reason is due to interfacial tension between the oily phase and aqueous phase. Clear? And the second reason is due to due to coalescence due to coalescence of okay, so the second reason is due to coalescence of all the globules. So these two reasons is the most important factor to immiscible liquids. So why these two immiscible liquids, sorry, why these two liquids are not miscible to each other? Due to these two main parameter. So first one is due to interfacial tension between the oily phase and aqueous phase, and the another thing is due to coalescence of all the globules. So what is that? So first of all, you should know. Okay, so listen carefully what I am telling. Suppose suppose in this beaker you have to take some water part, okay, and then you have to pour some oil part, okay. So first of all, you should take some water part in this beaker. Then after that, you have to pour some oil part in this beaker or in the water molecules. Okay. So when you have to pour the oil molecules on the water molecules, in that time, what will happen? Definitely, suppose this one is the oily phase. Okay. So definitely in that time, when you have to pour the oil molecules on the water molecules, it creates a large globules. It creates a large globules on the surface of the water. So why these two liquids are not miscible with each other? So the first point is, due to interfacial tension between the oily phase and aqueous phase. So this one is oily phase and this one is aqueous phase. Okay, definitely. Okay, definitely there is some interfacial tensions are there. That's why. Okay, that's why the two liquids are not miscible with each other. So when I will reduce the, okay, so when, listen, so these are the aqueous medium. Sorry, this one is the aqueous medium, and this one is the interfacial tension between the oily phase and aqueous phase. And when I will reduce the, okay, when I will reduce the interfacial tension between the oily phase and aqueous phase, in that time definitely this oil part dipped inside the medium. Here, okay, so the first reason will be solved. So how it will be solved? Now when I will reduce the interfacial tension in between the oily phase and aqueous phase, in that time it dipped inside the medium. So how to reduce the interfacial tension in between them? Now when I will add the third agent, that is emulsifying agent. So by the help of emulsifying agent, or when you have to add the emulsifying agent in this medium, in that time due to adding the emulsifying agent, it reduced the interfacial tension between the oily phase and aqueous phase, and in that time this oily phase dipped inside the medium. Clear? And the second reason, let's clear. Okay, the second reason is due to coalescence of all the globules. Okay, so what do you mean by coalescence? Coalescence means what? Now, coalescence means that is joining or merging of all the globules and to form a one mass of globules. That means, okay, so what do you mean by coalescence? Now, coalescence means joining or merging, okay, joining or merging of all the globules and form a one mass. Okay, that means after when you have to pour the oil part inside the water medium, in that time after trituration you have to triturate for the miscibility. Okay, so after trituration properly, definitely this globules part converted into the small globules. Okay, definitely after trituration these large globules converted into the small globules, but after some time, okay, after some time all the globules are recoalesced. Okay, all the globules are recoalesced, so that is means coalescence. Okay, so when all the globules are recoalesced to each other, that means when all the globules are merging together or joining together and it form a large mass of globules, definitely in that time it leads to separate to each other. So when I will prevent the recoalescence of the globules, okay, when I will prevent the recoalescence or when I will prevent the merging of each and every globules, definitely it cannot form a large globules, it cannot form a large globules, and definitely it cannot leads to separate to each other, and in that time it miscible with the oily phase and aqueous phase, and it prepare or it formation of stable emulsion. So the second problem is solved. Okay, so due to coalescence of all the globules, that means, so how to prevent, okay, how to prevent recoalescence of each and every globules? Now when I create a barrier in between the globules, I create a barrier in between the globules, or when I will create a film on the surface of the globules. Clear? So when I will create a surface, so listen carefully. So these are the globules. So these are the small globules. After recovalence, it form a large globules and it leads to separate to each other. Okay. So how it prevent the valences of the all the globules? Now by addition of emulsifying agent, okay, by adding the emulsifying agent, when I will prevent or when I will create a barrier in between the globules, so that is the barrier part. Okay, so when I will create a barrier in between the globules, then definitely the globules are not covalent to each other. Okay, or when I will create a film on the surface of the globules. Okay, when I will create a film on the surface of the globules, definitely it prevents the recovalence of the each and every globules, and so that's why it cannot form a large globules and it cannot separate to each other. So that is the importance of the emulsifying agent. So by adding the emulsifying agent, so you have to prevent these two parameters. That's why you have to prepare the stable emulsion. Clear? So that is the importance of the emulsifying agent, and that's why it is the most important parameter in the preparation of stable emulsion. So what do you mean by emulsifying agent, or what is the definition of the emulsifying agent? Now emulsifying agent are the substances, okay? So emulsifying agent are the substances that is used as a surfactant, that is used as a surfactant. Okay, so agent are the substances which are used as a surfactant. So what do you mean by surfactant? All of you know. Now surfactant means it is a surface active agent. It is a surface active agent. Clear? So it is a surface active agent and reduce. Okay, after adding the surfactant or after adding the emulsifying agent, it reduces the interfacial tension between the oily phase and aqueous phase, and it prevents the coalescence of all the globules. That's why it form a stable emulsion. So that is role of the emulsifying agent, or that is called as the emulsifying agent. Clear? And now the next point is, what is the other name of the emulsifying agent? Okay, what is the other name of the emulsifying agent? The other name of the emulsifying agent is emulsifiers. Okay, so what do you mean by emulsifier? Don't be confused, my students. So emulsifier means it is also called as a emulsifying agent, or the another name is emulgents. Okay, emulgents. Clear? So one is emulsifier, another one is the emulgents. Clear? So these are the two alternative name of the emulsifying agent. Okay, in the question paper, maybe arise what do you mean by emulsifier, or maybe arise what do you mean by emulgents. Okay, what do you mean by emulgents? So don't be confused. So it is also called as the emulsifying agent, and it is also called as a emulsifying agent. Clear? So now come to the point. So already I had discussed regarding the classification of the emulsifying agent, and second thing I had discussed regarding the definition of the emulsifying agent. So now come to the point, how to choose. Okay, how to choose which one is the best emulsifying agent for a particular type of emulsion. That may be O by W type of emulsion, or that may be double by O type of emulsion. So for the preparation of oil in water type of emulsion, which type of emulsifying agents are used? Or for the preparation of water in oil type of emulsion, which type of emulsifying agent you have to choose? Clear? So how it is possible? Because all of you know, just I had discussed in this class classification of emulsifying agent. In this classification, just in this class I had discussed regarding the classification of emulsifying agent. So in this classification, all of you learn there are multiple numbers of emulsifying agent which are available to prepare the stable emulsion. Prepare the stable emulsion. Okay, so how to choose from the multiple numbers of emulsifying agent? How to choose which one is the emulsifying agent is the best emulsifying agent for the preparation of O by double type of emulsion, or for the preparation of double by O type of emulsion? Because sometimes what will happen, sometimes no emulsifying agent possesses all the properties for the preparation of stable emulsion. So what do you mean? That means, when all of you know, what is the composition of the emulsifying agent? Now oil, okay, oil, water and gum. That means it is the emulsifying agent. So my question is that no emulsifying agent possesses all the properties for the preparation of stable emulsion. That means एमती किसी emulsifying agent नहीं जहाँ की multiple properties अच्छी. That's why you have to choose particular type of emulsifying agent for the preparation of stable emulsion. So definitely in that time it is required instead of one emulsifying agent you have to choose two or more emulsifying agent for the preparation of stable emulsion. Clear? So what I'm telling, what is the composition of the emulsifying agent? Now oil, water and emulsifying agent. Clear? But एमती किसी emulsifying agent नहीं, एमती किसी single emulsifying agent नहीं जहार multiple properties अच्छी, and you have to choose such type of emulsifying agent for the preparation of stable emulsion. Okay, so एमती किसी particular और एमती किसी single emulsifying agent नहीं जहार बहुत गुड़े properties अच्छी for the preparation of stable emulsion. So in that time it is required to take a two or more emulsifying agent instead of one. A good emulsifying agent जगह हमें सही जगह दरकार हो चुका ना, two or more you have to take the emulsifying agent for fulfilling the or for the preparation of stable emulsion. So for the preparation of stable emulsion, sometimes you have to take two or more emulsifying agent instead of one emulsifying agent. Okay, when you have to take two or more emulsifying agent, so in that time how to prepare the emulsion or how to prepare the stable emulsion. So in that time so many questions will be arised in that time. So to solve such type of problems, so that means how to calculate or how to maintain or how to take the particular amount or how to balance the emulsifying agent for the preparation of stable emulsion. So in that time to maintain or to balance the emulsifying agent, okay, in the preparation of stable emulsion, in that time a scientist initiated whose name is Griffin. A scientist who's initiated and he developed a scale, okay, whose name is Griffin. In that time, Griffin scientist developed a scale, okay, developed a methods, okay. So which type of methods they will develop now for the prevention? Sorry. So which type of methods the Griffin has developed? Now in that time the Griffin devised a method to or for calculating balanced mixture of emulsifying agent for the preparation of particular type of emulsion, particular type of stable emulsion. Okay, so in that time when the multiple numbers of emulsifying agents are there, and in that time how to choose the particular type of emulsifying agent and how to balance the emulsifying agent in the preparation of stable emulsion. To solve such type of problems, in that time a scientist whose name is Griffin is initiated and started or is developed a methods or a scale. He develops methods, and that method is for calculating balanced mixture of emulsifying agents for the preparation of particular type of stable emulsion. Okay, so for the preparation of particular type of emulsion, the Griffin scientist has developed a method. That what is the main purpose of the method? Now, for calculating the balanced mixture of emulsifying agent. Okay, for calculating the balanced mixture of emulsifying agent. So that's why you have to prepare the stable emulsion. Okay, so how to explain this method? So how to explain this method? In that time, the scientist developed a scale to explain such type of methods. Okay, so to explain such type of methods, they developed the scale. So which type of scale? That scale name is HLB scale. That scale name is HLB scale. That means what? That means, okay, so what do you mean? That means hydrophilic, that means hydrophilic, lipophilic, balanced. Okay, okay, so in that time the Griffin scientist has devised a method. So for calculating the balanced mixture of emulsifying agent for the preparation of particular stable emulsion. Okay, so how to explain this method? Now in that time again he developed a scale to explain the such type of methods. So which type of scale? And that's name is HLB scale. So what do you mean by HLB scale? Now H for hydrophilic, L for lipophilic, B for balanced. That scale name is hydrophilic lipophilic balanced. And that scale, or according to that scale, okay, according to that scale, you have to choose the best emulsifying agent, or you have to choose the particular type of emulsifying agent for the preparation of particular O by double type of emulsion or double by O type of emulsion. Okay, so definitely your problem has been solved by using the HLB scale. That means which type of emulsifying agent, because so many multiple numbers of emulsifying agents are there. So how to choose which one is the best emulsifying agent for the preparation of particular type of emulsion? Clear? So according to the HLB scale. So now let's see what do you mean by HLB scale, or which one is the HLB scale. All of you know HLB scale means, or what is the definition of the HLB scale? It is a hydrophilic lipophilic balance. But actually, what is the HLB scale? So let's see the diagram so that you can easily understand what you mean by HLB scale and how to perform the HLB scale, or how to perform the HLB scale, or by using the HLB scale, how to choose the particular type of emulsifying agent for the preparation of stable emulsion. Clear? So let's see the HLB scale. Okay, in this scale, the Griffin scientist divided 18 units. All of you know, in the scale is almost the mark of 1, 2, 3, 4, 15, 13 up to 100. Yes or no? ठीक सेमती गोटे स्केल जदि आम कहवा ये गोटे हूँ स्केल. ओके, स्केल 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 etc. ओके, along infinity. ये सब मेंशन हो गोटे स्केल. ठीक सेमती in the HLB scale, the Griffin scientist divided into 18 units. Okay, up to 18 units. Okay, up to 18 units, and 8 to 18 units having hydrophilic nature, okay, and 0 to 8 or 0 to 6 or 3 to 6 units having lipophilic nature. Clear? That means in this scale, in the HLB scale, the Griffin scientist divided into 18 units. Clear? 18 units. So those emulsifying agent, okay, each and every emulsifying agent have a specific number. Okay, each and every emulsifying agent have a specific number. So according to the specific number of emulsifying agent, which emulsifying agent under the 8 to 18 units, in that time such type of emulsifying agent definitely that is under the hydrophilic nature. Okay, those emulsifying agent having 8 to 18 units, such type of emulsifying agent you have to choose for the preparation of O by W type of emulsion. Why? Now all of you know you what to mean by hydrophilic. Now hydrophilic means it is the water soluble part, or hydrophilic means it is the water loving part. Clear? So that's why those emulsifying agent having 8 to 18 units, because each and every emulsifying agent have a specific unit, or each and every emulsifying agent have a specific number. So those emulsifying agent under the 8 to 18 units, definitely such type of emulsifying agent you have to choose for the preparation of O by W type of emulsion. Why? Now because these are showing, or these are shows the hydrophilic nature, and those emulsifying agents having 0 to 6 or 3 to 6 unit, okay, that such type of emulsifying agent shows the lipophilic nature. So all of you know what do you mean by lipophilic nature? Now that means it is the oil soluble. It is the oil soluble, or it is the oil loving. That means when you have to prepare the double by O type of emulsion, okay, when you have to prepare the double by O type of emulsion, in that you have to choose which type of emulsifying agent under the 3 to 6 or 0 to 6 units. Those emulsifying agent under the 3 to 6 units, definitely in that time you have to choose for the preparation of double by O type of emulsion. Why? Now because such type of emulsifying agent shows the lipophilic nature. Clear? So that is the HLB scale. So let's see again the clear diagram of HLB scale. The clear diagram of HLB scale. So okay, so let's see. So that is the particular, or that is the schematic diagram of HLB scale, Okay, so that is the schematic diagram of HLB scale. So what do you mean by, or what is the full form of HLB scale? Hydrophilic Lipophilic Balanced. So what is the main purpose of the HLB scale? Now for calculating, okay, for calculating balanced mixture of, emulsifying agent for the preparation of a particular type of stable emulsion. Clear? So in the exam point of view, some question or some 1 mark question will be arise. What do you mean by HLB scale? In that time you have to say, or in that time you have to mention, so it is a hydrophilic lipophilic balanced scale. Clear? So it is used for calculating, the balanced mixture of emulsifying agent in the preparation of a particular type of stable emulsion. Clear? So this is the schematic diagram of HLB scale. So according to this scale, or according to the HLB scale, or according to the SLB value, okay, according to the SLB value, you have to easily choose which type of emulsifying agent is best for the preparation of O by W type of emulsion or double by O type of emulsion. So how? Now according to the HLB value. So why? Now because each and every emulsifying agent have a specific number or have a specific value. Okay. So when you have to put this value in the HLB scale, you can easily identify which type of emulsifying agent shows the hydrophilic nature, or which type of emulsifying agent shows the lipophilic nature. So that's why the Griffin scientist has divided the scale in 18 units. Okay, 18 units, 0 to 18 units. Clear? So those emulsifying agent under 8 to 18, that is under the hydrophilic, or those emulsifying agent, or those emulsifying value number under the 8 to 18, that's a such type of emulsifying agent shows the hydrophilic nature. That's why you have to choose such type of emulsifying agent for the preparation of O by W type of emulsion, for the preparation of O by W type of emulsion. Or the second thing is those emulsifying agent value 0 to 6, or you can say 3 to 6. Clear? 3 to 6 or 0 to 6. Those emulsifying agent value under the 0 to 6 or 3 to 6, such type of emulsifying agent shows the lipophilic nature, and you have to choose such type of emulsifying agent for the preparation of W by O type of emulsion, for the preparation of W by O type of emulsion. Clear? And some another example of emulsifying agent, and those emulsifying agent under 1, 2, 3, that is under the anti-foaming agent, emulsifying agent, because all of you know so many different types of emulsifying agents are there. Okay, and those emulsifying agent value under the 0 to 3, or sorry 1 to 3, that is under the anti-foaming agent, and some 7 to 12, sorry 7 to 11, that is under the wetting and spreading agent, and some detergent emulsifying agents are there, that is those emulsifying value having 13 to 16, that is under the detergent emulsifying agent, and 16 to 18, that is under the solubilizing agent emulsifying agent. Okay, so that is the complete explain of HLB scale or HLB value, that means hydrophilic lipophilic balance. So according to the HLB value, you can easily identify which type of emulsifying agent is best for the preparation of a particular type of emulsion. Clear? So let's see some emulsifying agent value so that you can easily understand what I am telling. Okay, so that you can easily understand what I am telling. Suppose acacia, so my dear students, so let's see some examples of emulsifying agent. Okay, so that you can easily understand, which one is the, or which type of emulsifying agent is best for the O by W type of emulsion, or which type of emulsifying agent is best for the W by O type of emulsion according to the HLB value. Clear? According to the HLB value. So first one is the acacia. So acacia is the emulsifying agent. So acacia HLB value is 8. So what is the HLB value of acacia? 8. So now tell me, the acacia HLB value 8, which type of emulsifying agent, or you have to choose for the preparation of which type of emulsion? Definitely 8. That means all of you know 8 to 18. Okay, that is under the hydrophilic nature, and the acacia HCl value is 8. Definitely that is the O by W type of emulsifying agent. That means when you have to prepare O by W type of emulsion, in that time you have to choose some acacia. Clear? And next one is the glyceryl monostearate. Okay, so what is the HCl value of glyceryl monostearate? And the HCl value is 3.8. So let you know 3 to 6 or 0 to 6. So that is under the, so the lipophilic, listen, 3 to 6. Okay, sorry, 3 to 6. Okay, or 0 to 6. These are under the lipophilicity, or these are under the lipophilic nature. Okay, so glyceryl monostearate HCl value having 3.8, and definitely that is under the W by O type of emulsifying agent. And when you have to prepare W by O type of emulsion, in that time you have to choose the glyceryl monostearate. Clear? And another example is sorbitol monostearate, having the HCl value is 4.7. Definitely 4.7, that means this part. And obviously those emulsifying agent under this part that is shows the lipophilic in nature. So obviously the sorbitol monostearate is a W by O type of emulsifying agent, and when you have to prepare the W by O type of emulsion, in that time you have to choose the sorbitol monostearate. Here, next one is the tragacant 13.2. Okay, tragacant 13.2. So let's see 13.6 or 13.2. That means this part or this part. Okay, and all of you know 8 to 18. 8 to 18 shows the hydrophilic in nature. That means the tragacanth under the O by W type of emulsifying agent. And when you have to prepare O by W type of emulsion, in that time you have to choose some tragacanth. Next one is the triethanolamine oleate. So having HLB value is 12.0. Definitely this part. Okay, so that's why it is definitely it is under the hydrophilic in nature, and when you have to, or it is a O by W type of emulsifying agent. When you have to prepare O by W type of emulsifying agent, in that you have to choose the triethanolamine oleate. Here, so that is the complete part of the HLB value. So in this class, I had discussed. So in this class, I had discussed regarding the emulsifying agent. What do you mean by emulsifying agent? What is the importance of the emulsifying agent? And classification of emulsifying agent according to the different sources and HLB value. Okay. So this class is very important for you, my students. Clear? Thank you very much.